So the other day, you were assigned to sketch a model, a graph of a person riding a Ferris wheel over time. So I believe the video looked something like this. So person riding a Ferris wheel. And this seemed to be the highest point, and highest point actually stops at about 3 seconds. And if we, so that will be, that will be one rotation. And then if we go another rotation, it takes about 12 seconds to go 2 rotations. So looking at the video, let's take a look at the diagram to see what was needed for you to plot these heights over time. So I believe they told you that the person who's riding it is 2 meters above the ground. So 2 meters. So this over here from the ground was 2 meters. They also said that the radius of the circle was 10. So this was 10. This was also 10. So that's good. So another feature that we have is, since this is the max height as a person is riding the Ferris wheel counterclockwise, the highest point would be 22 meters high. So the 22 meters high will be the max point. And then what are some other features? So all these, the circles seem to be sectioned off as 8, so it seems like all the sections are 45 degrees. So if you wanted to figure out the height here, you could have also figured out the height whatever time it landed. You could have figured out the height here. Since this is 10, that means that this will be the reference angle. So here, these legs would have been 10 divided by radical 2. Which would have been about 7 point something. And then you would have added that to, so this one is 12. And you could have added that, which would have been about 19 or so, 19, 18 estimated. So you could have found all those points as the Ferris wheel were to rotate. So to find the points, or find the easiest points, I would have found the points that would actually land on 0 degrees, 90 degrees, 180 degrees, 270 degrees, and going back to 360 and so forth. So if you found the time and the height at these points, it probably would have been the easiest, because to find these, just like we had to find the reference angle 45, then you had to do some calculation in the calculator to find the values. So for here, I would have found that, at this time, it would have been 12 meters. Whatever time that it landed here would have been 22 meters. Whatever time it landed over here would have been 12 meters. And then back to the original spot would have been 2 meters. So if you notice, the cycle keeps repeating itself. So when you graph it, it will look something like this, where it started at 2 meters at time 0, and it hits the max at the highest point of the Ferris wheel, and then it comes back down. So this was one cycle, or one rotation of the Ferris wheel, and another rotation, and it repeats the cycle in the same behavior. Now, this type of function is called, and many of you got it right, it's called a trigonometric function. Now, it is very specific trigonometric function. It actually looks similar to a sine and a cosine curve, and we call these functions a sinusoidal functions. And these have a very unique characteristics where they have a periodic behavior. Now, what is a periodic behavior? Let's go over the term. So just as the Ferris wheel shows a periodic behavior is actually defined as it repeats its values in a regular period. So the period is the length of time it takes for a cycle to repeat itself. Now, there are a lot of different examples in real life that shows a periodic behavior. The length of the day, or depth of the water of the high tide of a low tide. The temperature within a year of a country. So all of these show a periodic behavior. Now, this Ferris wheel showed a periodic behavior. So how will we figure out the period? Now, period is actually the length of time. So what was one period of this Ferris wheel? It was about 8 seconds. 8 seconds was one period. That's how we identify period. Basically, one length of one cycle. Now, repetition over a fixed cycle. A period relation is one which repeats itself over in a horizontal direction. So the pieces or the one cycle from the graph have to show the same behavior horizontally, not vertically. So let's take a look at some of these examples. So this example, first one, shows that, one cycle is 360 degrees. So a period in this case would be 360 degrees. So here P equals 360 degrees. So length of one cycle. Now let's look at another example. This starts at some height, it looks like about 18, and it goes back down and comes back up somewhere over here, and that seems to be one period. And so one period in this case would be 2, maybe this seconds, as for seconds, so 2 seconds will be one period in this model. So let's look at another example. Well, this one starts over here. The ending position has to be the same. So this one seems to show a periodic behavior, and it goes up, it stays constant, goes back down, and it starts another pattern, same pattern, and stops here. So it seems like here the period is about, goes up to 7, and then so it's about maybe 7.5 or 7. So we're estimating, so we can say 7.5 because over here it seems like it's 15. So let's say it's 7.5. So let's look at the last example here. Now, unlike the other ones that has a pattern same across horizontally, this one seems to be changing where there's a vertical change. Now, when there is a vertical change, this cannot be identified using a periodic behavior. So this one has a vertical change. So this one has no periods, no periodic behavior. I'm using my mouse so I can't even spell properly. So this one has no periodic behavior. Okay, so you're gonna try the other examples where you're going to identify, do they have a periodic behavior, and show an estimation of a length of one cycle, so one period.